Let us greet our guests with a round of applause. Kindly take your seats. The chief guest of today's program, Honorable Dr. Manimori Theodore, outstanding scientist and former chief coordinator, ISRO DRDO Gaganyaan program. Guest of honor, Dr. Milind Atre, INOX chair professor of cryogenics, Department of Mechanical Engineering, IIT Bombay. Reverend Father Dr. Paul Chandran Kunel, director of St. Vincent Pallotti College of Engineering and Technology, Nagpur. Reverend Father James Thomas, assistant director. Reverend Father Siju Jose, financial administrator. Professor R.B. Govardhan, institute mentor. Dr. Surendra Gole, principal. Dr. Manoj Brahme, coordinator, distinguished head of the departments, in charges, faculty members, and my dear students. A warm good morning to each one of you. I, Professor Abronil Banerjee,
and I, Professor Madhura Kulkarni, welcome you all for this opening ceremony of Vicennial Year and Engineers Day celebration. It is indeed our signal honor to welcome you all today at our campus, St. Vincent Pallotti College of Engineering and Technology, Nagpur, managed by the Nagpur Pallottine Society that aims at helping its members realize spiritual and moral as well as intellectual and aesthetic values.
Pallotti in its euphoric 20. 2 decades of excellence and experience shared across thousands of candidates excelling in various fields across the globe. Today, when we stand together to mark the beginning of the 20th celebration of this institute, we promise to shine ever brightly and eminently. It is matter of immense pride that we celebrate Euphoric 20 through a youthful Engineers Day celebration.
With this, I now request the dignitaries, our chief guest, guest of honor, Dr. Father Paul Chandan Kunel, Father James, Father Siju, Dr. Gore, and Professor R.B. Govardhan, Dr. Manoj Brahme, Mrs. Rajeshri Panikar, and students on the dais to join for lighting the traditional lamp.
let me now invite Professor Siju Samuel to lead us through the prayer.
Kindly rise. Today's scripture reading, the book of Matthew, chapter 5, verse 13 to 16. You are the salt of the earth, but if salt has lost its taste, how shall its saltiness be restored? It is no longer good for anything except to be thrown out and trampled under people's feet. You are the light of the world. A city set on a hill cannot be hidden, nor do people light a lamp and put it under a basket, but on a stand it gives light to all in the house. In the same way, let your light shine before others, so that they may see your good works and give glory to your Father who is in heaven. Let's pray. O gracious and heavenly Father, as we gather here today to mark the beginning of this Vicennial year, we come before you with hearts full of gratitude and hope. We thank you for the countless blessings you have bestowed upon us over the past 2 decades. In this special year, we seek your guidance and wisdom. May your light illuminate our path, and may your grace be our constant companion as we embark on this new chapter of our journey. We ask for the strength to face any challenges that may come our way, and the courage to seize every opportunity for growth and transformation. Let this Vicennial year be a time of renewal, both in our personal and professional lives and in our collective endeavors. Lord, grant us the ability to serve others with love and compassion, to build bridges of understanding and unity, and to make a positive impact on the world around us. May we continue to grow in faith, hope, and love. We commit this Vicennial year into your loving hands, trusting that with you all things are possible. Bless us abundantly, Lord, and may your presence be felt in every moment of this year. Here ends the scripture reading. Please be seated.
Thank you, sir. To embark the tradition and make this event a graceful one, let us have the welcome dance.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि
एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि
गानचतुराय गानप्राणाय गानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुपूजिताय गुरुदैवताय गुरुकुलस्थायिने गुरुविक्रमाय गुह्यप्रवराय गुरवे गुणगुरवे गुरुदैत्यकलक्षेत्रे गुरुधर्मसदाराध्याय गुरुपुत्रपरित्रात्रे गुरुपाखण्डखण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढगुल्फाय गन्धमत्ताय गोजयप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि
एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि
Thank you. I now request our director, Reverend Father Paul, to welcome our chief guest, Honorable Dr. Manimori Theore, with a floral bouquet.
Thank you, Father. Thank you, ma'am. I now request our principal, Dr. Surendra Goe, to extend a floral welcome to our guest of honor, Dr. Milind Atre. Thank you, sir. We would like to request our Honorable Chief Guest, Dr. Manimori Theodore, and our guest of honor, Dr. Milind Atre, to inaugurate the Vicennial celebration. For this, I would like to call our Iantra students team to lead us.
Thank you. The word euphoric in the logo describes an intense feeling of happiness, excitement, and joy. 20 years stands to mark the Institute's 20-year milestone. I would now request Director Father Paul to address the gathering.
Honorable Chief Guest, Dr. Manimari Theodore, our guest of honor, Dr. Professor Milind Atre, Principal Dr. Surendra Gole, members of the management, Professor Govardhan, Dr. Manoj Brahme, the chief organizer of this program, and his team, and all of you faculty members, and above all, my dear students. St. Vincent Pallotti College, which was established in 2004, is into its 20th year. And we want to make this a memorable occasion by organizing year-long programs, all directed towards the enrichment of the students, the faculty members, and the institute at large. And we thought that this celebration, this inauguration, should be flagged off on the most important day for engineering students, namely the Engineers' Day. Originally, it was scheduled for the 15th, that is the Engineers' Day. But unfortunately, or fortunately, that was declared as a holiday, and we had to anticipate this celebration by one day. Unfortunately, call it a blessing, both our guests, our chief guest and the guest of honor were available, and we are extremely happy that they have adjusted to our situation, our requirement, and responded very, very positively and enthusiastically to our request. Thank you so much. This is an occasion to seriously consider the profession of engineers, their roles and responsibilities. Today we know that we cannot rest content with the conventional styles of being an engineer. The requirements of engineering are so great, so vast, sometimes it seems to escape our grip. And that is why we have all the more reason to ensure that everything within our possibilities is done in order to master this profession, in order to equip oneself with the requirements of modern engineering profession. And this is certainly the first institute-level celebration of the Engineers' Day. And I believe that this is not going to be an isolated celebration. Rather, it is going to be an annual phenomenon where every member of the institute will celebrate this enthusiastically. We will ensure that this is celebrated in the most fitting manner with a day-long or several days of celebration involving every student. And the whole concept behind this celebration is to ensure that every student is somehow caught up in this engineering profession seriously consider his or her responsibilities in this 4 years of their presence here and equip themselves in the best manner possible for the profession that lies ahead of them. Your future depends on what you make of these 4 years here. Today, unlike in the past, you have excellent opportunities in the engineering domain, provided you prove yourself competent. Ordinary, listless people have no chance. It has become a world where the fittest alone will survive. And therefore, ensure, my dear students, that you make the best of the opportunities that are given to you. And I thought we should get very many eminent men and women into the campus who will keep the students on a great high. Students must be motivated and they should remain focused. And I thought the best way to do that is to have eminent men and women, great personalities who have proved their mettle in the field of science and engineering. And today we can be very, very proud and we can rejoice that we have some of the great personalities of our country present with us who have done yeoman service and continue to do so, both for the nation and for the institutions to which they belonged. We have Dr. Manimuri Theodore, the coordinator of ISRO DRDO Gaganyaan project. We are still in the euphoria of the successful launch of the Chandrayaan. We are taken to the moon and some of us are still there celebrating, rejoicing, meticulously following the latest developments and even with our crossed fingers waiting to see whether that rover which was put to sleep will come alive when the sun dawns on it. And I thought these two people, our chief guest and the guest of honor, are also people who have contributed in a big way to the exploration of space technology. One in the Gaganyaan project and the other in the development of the cryogenic engine which propels the rocket far high into the space. We have to celebrate this day, my dear students, my dear faculty members, with the presence of these eminent men and with the progress and achievements that we have made in the field of science and technology. You have a very, very positive environment today, not only in the institute, but also in the country at large, where excellence is sought after, where excellence is rewarded in a big way. Get caught up in this process, involve yourself most personally and enthusiastically, and make the best of the opportunities that are given to you. Thank you. Have a great day.
Thank you, Father. Today we are honored to have with us Dr. Milind Atre as the guest of honor for today's program. Professor Milind Atre is the Inox Chair Professor of Cryogenics in the Department of Mechanical Engineering in IIT Bombay. He served as a Dean R&D of IIT Bombay for over 4 years and as Professor in charge of SINE, Society for Innovation and Entrepreneurship, a business incubator at IIT Bombay for over 6 years. He is currently the president of India Cryogenics Council. He is the member of International Cryogenic Engineering Committee, ICEC, and also serves as the member of International Editorial Advisory Board of the journal Cryogenics. Professor Atre is the recipient of various awards, namely the Professor Sukhatme Award for Excellence in Teaching, Dr. Patwardhan Technology Development Award, the Industrial Impact Award, and the Excellence in Teaching Award. He has been entrusted with various projects related to defense, space, and atomic energy applications. I request Dr. Milind Atre to address us.
Good morning. Can you hear me? Is that working now? Should I put this off then? I mean, is it on right now? No. Good morning, everybody. Today's chief guest, Dr. Manimozi Theodore, outstanding scientist and former chief coordinator of ISRO DRDO, Honorable Director Father Paul, Assistant Director Father James, Financial Administrator Father Siju, my friend and principal here, Dr. Gole, Professor Govardhan, and the program coordinator, Dr. Brahme. It's my privilege and honor to be here on this very important day, what we call as Engineers Day. In fact, I should accept the fact that possibly for the first time, I am attending such a celebration on the very important day for all of us, which is the Engineers Day. In spite of all of us being engineers, still, we don't celebrate such a day, such a great day, and very happy to see all of you today in this function. Well, engineers make a huge impact in everybody's life. Right when I come from Mumbai to Nagpur, and I come to the airport, and when I come to the big road here, I start seeing the things that have been done here in Nagpur, and very unique combination having 3 horizontal lanes. You got a road, you got a flyover, and you got a train, a metro train going. I wish such models could be carried out all over the world, but very happy to see that this is being carried out in Nagpur. And also very good to see, and maybe that is because I came from Mumbai and Dr. Manimozi comes from Bangalore. When we come down to Nagpur, we see absolutely delight while traveling on the road. I don't have to wait anywhere for more than 20 seconds. While many times we have to stay for over 10 minutes and 15 minutes at various corners in Mumbai and Bangalore. So that's a delight to watch and see, and very happy to see that Nagpur is actually showing the marvel of real engineering, where a lot of money, a lot of hands, a lot of people coming together, and the engineers who work toward the design of such a thing, actually converting those design on paper to actual, where actual bridges are built, actual flyovers are happening, and actual trains are moving around the road. So transportation is a very important engineering aspect, which you always notice in Nagpur. And other than, of course, we got a beautiful city now that it is a green city also. So very happy to be amongst all of you. I have been here once before, maybe 4 or 5 years back, when we conduct GATE exam from IIT Bombay, and this is one of the centers. But very happy to come here and to address all of you on such an important day. So as I said, engineers are essentially a very, very important component of our society, very important part of our society, where the life is made luxurious, if not exactly luxurious, at least livable, because of the contributions that come from Engineers Day. And most important, it's celebrated on the birthday of Dr. Visvesvaraya. Very happy to tell you that Dr. Visvesvaraya is a product of COEP Pune, College of Engineering Pune. It's in Maharashtra. And also happy to tell you that I am on the member of a BOG of COEP Pune, and every time I go there, I see his picture right at the entrance of the Engineering College Pune. And that is a very important Maharashtra connection that we have with Dr. Visvesvaraya. When I talk about engineers, it's not only the things that get converted from, from the paper to the actual condition, to the actual hardware, to the actual product, to the actual technology. But engineers also demand, or engineers also should come up with the ethics, the dedication that they give, and actually to see the creativity in today's time. We got to see the innovation that they do, and of course, very importantly, the transparency in their work. I think for me, very important is today, not only to do something 100 times, but I should be able to see innovation that is driving this society to a very important direction. And the innovation, the collaboration, and the transparency in the work are very, very important. Many of you will tomorrow becomes, big CEOs of company, or managing directors, or engineers, or electronics engineer, mechanical engineers, computer science, artificial intelligence, things like that, and the list goes. But what is most important is to see that everything is done in the most cost-effective way, very innovative way, but more importantly today, it's done in a collaborative manner. You see the big mission that we've had just now, the Chandrayaan, we had almost 10,000 people working behind it. There are different units of ISRO, and I work with many of them. The UR Rao Center from Bengaluru, and then we have got centers in VSSC, LPSC, SAC, and there are several centers all over places who have contributed in terms of manufacturing, in terms of electronics, in terms of software, in terms of robotics. And all these are very important because ultimately all of these have come from different corners of India and possibly has got the integration done at one place. So somebody cannot ever say that I have done this, we have done this, and of course very importantly all of us, the nation, entire nation and its people have contributed towards this, and we are very, very proud of what has been achieved recently. What is most important point I want to direct to all engineers is the collaboration. The collaborative attitude, the knowledge sharing, and I've seen in many times among student community also that they would like to keep their knowledge for themselves. If I have understood a particular concept of, let's say I'm talking about mechanical engineering, I've understood a concept of fluid mechanics. And normally students, because everybody think about, immediate advantage, immediate goal, that I should understand this topic and I should get better marks. I will never possibly tell this concept to my students. But sharing knowledge with the students actually teaches you a lot. In IIT Bombay, I would always like to teach a course which I have never understood. Possibly I was weak in those courses. The best understanding happens when you actually deliver the course, when you actually teach the course. So exactly in a similar manner, if you actually tell or explain these concepts to your fellow colleagues, and when you graduate and become CEOs and big engineers, senior engineers, principal engineers, etc., the sharing of knowledge, what you know and what you don't know, if all of you put together and bring it to a table, and that is where the collaborations come. This branch of engineering, therefore, is ever evolving. You can see every generation. I belong to generation of 80 to 90 decade when I was student during those, and I did my BTech, MTech, PhD in line. At the age of 27, I was with a PhD. And then I understood how little I know. Because when you are learning, you come to know that, this is still vast, and then you understand and conclude that I hardly know about this topic. But I know the process, how to understand. I know how to read books, I know how to read journals, I know how to read the papers, research papers, how to write, and most importantly, how to communicate. These are various branches of engineers where the engineers should be able to communicate. The design that you have carried out has to be understood by others. Unless that happens, whatever you have done, you have to be able to communicate. Whatever innovation you have done, whatever design you have done, you have to communicate in the best possible manner. So 80s, 90s was a branch when we had just basic knowledge and the research word. Maybe I can take this mic. No, sure. So I think the 80s and 90s were those years where the learning happened. But after 90s, we started having research. And India really started contributing to the research papers in various journals, various international journals, and possibly some patents started happening from Indian context. But it's after 2000, when our software industry took off, we really started making ourselves felt all across the world. And it is after 2000 that we really got to understand what we are best at. So we got really into the crux of research and manufacturing later on, where we started that we can even manufacture things the best of our ability. Again, in Chandrayaan, if I talk, most of the manufacturing has happened at L&T and Godrej and various small sector companies where small parts were made. And those people have really contributed from wherever they are, the parts of Mumbai or Pune or down south and east and north, etc., etc. So this branch is evolving, and right now we're talking about innovation. After 2010, I think every college, every institute, every engineering college or even non-engineering college has started talking about innovation. And then we also started talking about business incubator. So many times I've seen that the professors receive grants, and these grants they use to develop some technology. Somebody graduates, somebody do their master's work, somebody does their PhD work, they publish papers. But whatever technology gets developed, whatever research happens, it remains in the four walls of the laboratory. And we at IIT Bombay have made a very conscious efforts wherein we have pulled in our students and they visit each and every lab and find out what is that technology which is at lower TRL level. TRL level, I'm sure you understand, technology readiness level. The TRL level of 3 and 4 that could be achieved in laboratory, and we understand that there is a need of such a product or such a technology outside, be it in healthcare, be it in mechanical engineering, be it in controls, be it in now artificial intelligence, and be it in the robotics. Such technologies are required now, and these students, who are very smart students now, actually understand whether these technologies are required outside, and they are the one who can actually then increase this TRL level from 3 to 7. And after 7, what we require is industry to come forward. So it's very important that these TRL levels get extended, and none of the research should happen in the four walls. None of the money that one has put into and one of the thoughts put into, they might have possibly research papers and patents, but very importantly, they should have the ability of converting these technologies into practice. It's very important for engineers to understand and all of us to understand that our research, our technology has to be relevant outside. There is no point in developing something and spending money which has no relevance outside of our institute, not just publishing papers. And this is what I tell at IIT Bombay also, that we don't want only publications happening. We would like to have more and more patents, and we would like to have more and more technology transfers. This tech transfer can happen to startup companies, can happen to big industries, and for which the institute has to really take up these as a priority. So we should also see that whatever project we give to our BTech students, the students should be able to realize that the problem that we are solving is not just for my curriculum. This is not my just credits. This problem is required outside. This problem solution is required outside. I mean, when I just go outside, I see a road which possibly has a fantastic connection, but the road from the big road to this road has a problem. Can we not do something about that? Can we have some technology over there? I know there could be a lot of political issues and, who will take care of such roads and all that thing, but I'm sure student community can find out ways and means to overcome such problems. They can come with a very innovative solution. Right opposite IIT Bombay, we got 7 roads coming at one point, and the chaos. Just crossing this road is absolutely impossible, especially in the mornings and in the evenings. And our community came with a sensor technology. They got some sensors, and we could actually find a solution to the problem that how do we cross. In fact, how do the old people cross the road? Because by the time you come in the middle of the road, the signal has gone, and the the faculty members and the old community of 70 plus cannot wait in the middle of a road. And there can we find such a solution. India is a place where opportunity is growing every day. We got so many opportunities here because wherever there are problems, there are opportunities. And now we should convert those opportunities as our business, as our technology statement or our research statement and find a solution to these problems. And I'm sure once you showcase these problem solutions, there'll be a lot of buyers. A lot of industry would be waiting for that. Student like you, see, most of us are very biased because we have seen this technology right from our 20s and 30s. But you guys are just 20 years old. And the way you think has to be in most innovative way because we are now thinking in a very traditional manners of a problem that we pursue right from our childhood. But when you see this problem from your eyes, you actually can find a beautiful, very, very innovative solutions. And the teacher's duty, therefore, to sort of, just encourage them, to give them the spark. The ignition will automatically happen. So this spark generation has to happen in an institute like this. And the student community actually has to come together. And again, I will say one student cannot do this. Can we have a group of students? Can we have 4 or 5 students coming together? And they have to be from different disciplines. They cannot be all electrical engineers or all can be mechanical engineers. Can they be one from mechanical, one from electrical, one from computer science, one from civil engineering? They come together, material science, they come together and find a solution to a problem. And the problem has to be actually from outside. The problem has to be absolutely relevant and corresponding even professors have to understand those problems and direct them. We don't require much funds for these things, only the direction that the student require. Of course, they require motivation and inspiration and maybe some credit for this also. And that is what now we say in the new NEP, that we have credit for such projects which has got relevance outside. IIT Bombay has been doing this since ages. We had our satellite Pratham launch from ISRO only. We had our racing car. But in spite of that, we have got several students coming together. I mean, we got 400 students coming together in entrepreneurial activity because we teach entrepreneurship and we take a minor degree program in entrepreneurship where the students have to find out technology problem again. And not social problems are very, very important, but being an institute of technology, we want them to find out a tech problem. And today, most of them are getting driven by artificial intelligence and data sciences. And let me tell you one thing, and I can share a very small anecdote with all of you. We had just had admission this year, and almost 200 students got admitted undergraduate to mechanical engineering. And when I went, and as a senior professor, our head of the department asked me to talk to the students. And I asked first question to the 200 students, that how many amongst you wanted to come to IIT Bombay as a first choice? And believe me, almost everybody raised their hands. The second question asked, how many amongst you wanted to become mechanical engineers? And then came, students wanted to hide their face, and possibly only 25 hands came up. And the third question I asked them, how many of you would like to do studies or research in artificial intelligence and data science? Almost everybody raised their hands. Now, this is a trend that we have to understand. And the next question I asked, how many of you would like to have a fusion of artificial intelligence and mechanical engineering? And almost everybody rose to the occasion. And that tells the student that we have to change ourselves, including the professors, including the teacher, that students have to understand artificial intelligence is not a very big deal. We possibly have been doing that since our mathematics, statistics, etc., etc. It is now that big data is there and computers are becoming very important, and they can actually crunch these numbers and find a pattern in the data that we have got. Can we now marry the artificial intelligence and data science to mechanical engineering? And this is very important because machines are there, and nobody has to be afraid that mechanical engineer or electrical engineer, they are very important branches. Believe me, they will never die. But every waviness comes in every section, over a period of time. And we happen to be this time because when we were students, electronics came into picture. There was no electronics at VNIT Nagpur then. We had only mechanical, electrical, civil, metallurgy. And then everybody said now electronics, and then the computer science. And that's what computers will replace everybody and the job will be lost. Nothing of that sort has happened. Similarly today, we have to train our student and possibly have a course on why not artificial intelligence in machine learning in mechanical engineering. And that is what we have started doing. At IIT Bombay, we have started a new course in mechanical engineering, when we would like to give examples from mechanical engineering, wherein artificial intelligence and machine learning have giving mechanical engineering example have been taught to students. I'm pretty happy everybody is very about. So these branches require these corrections. We say midlife correction. It's like got mid-course correction now that we have to do. And there are, don't worry that mechanical engineers, electrical engineers, very important. Controls have to be there. The machines have to be built up. The levers and the gears and will always will be there. All right. So we always require air conditioners and refrigerators at home. So similarly, we always want roads, we want flyovers. But why not track the data that we get when the people are going from our airport to central Nagpur? We can actually track the patterns in the transport that happen with time every day and every season. And I'm sure a lot of data can be generated, and you can actually effectively have less people guarding the transport sector. That that you require more and more people on these days of the season or this time in a day. And accordingly, actually, we can do a lot of implementation of those, provided the data is made available. So what we require is all sensors. We all require video cameras and collect data from some place, and somebody has to analyze this data and accordingly do the corrections that will benefit all of us. Similarly, I see different machines are failing at different times. So all these periodic inspections can actually be done by the data that you get from the accelerometers, from the noise, from the decibel levels over a period of time, and you can come to a lot of conclusions. And the mechanical engineers, therefore, would have to do something else and need not do the maintenance all the time, but possibly do the design and possibly understand more about sensors during this period. So never the jobs are lost when corrections in the program happen. I'm sure Dr. Manimuri will possibly talk about this because she heads the Center of Artificial Intelligence and data with respect to DRDO and every machines. So I believe that the Chandrayaan, Gaganyaan, you saw the pattern. You saw Chandrayaan when the rover landed, right? There was nobody to guide, either aa jao, right mein aa jao, piche jao or something. It was all taking autonomous decisions. They were all cameras, and those cameras, the photographs and the videos that were converted into decision making. So all these decisions were actually directed by the data they received. But they were all robotics, they were all legs, they were all, they were all basically degrees of freedom, and all those studies must have gone through this before they make those rovers. And the robots that came about, all people of different disciplines, controls, system and control, all these people have driven such things. So very importantly, such decision, and that's why it would land properly at a place. So it actually says, can I park my car here? Exactly like that. When I go to a parking thing and in a parking lot and I see, some places where are flooded, there's water. And I say, I don't want to park my car here, I will go somewhere else. Exactly that the lander was doing there, possibly sensing which is the best place to park my car. And the decisions actually were taken based on the sensors and the videos it took when it was flying down there in the orbiter. My important contribution, therefore, is what I believe today, there's a whole lot of changes that happen in technology. For example, semiconductors is a huge thing, and Government of India is investing a lot in this technology. And all of us have to rise to the occasion that we have to make chip ourselves. So Make in India concept is really, really flourishing, really, really dominating, and the money to sort of give and have such centers is very, very important. We have at IIT Bombay very important fab lab. Very few places have such fab labs, IISc Bangalore, IIT Bombay, and a few other places. And we're working very closely. In fact, the whole big team of ISRO was there just 2 days back at IIT Bombay to develop a chip. And we have got chip making. We cannot make numbers, but we can make 1 or 2 chips. We can design that. So that is possible. We're also doing a very important transition in energy sector today. Hydrogen will become very important in the time to come. And of course, hydrogen is all around us. We got water, and therefore we got to have electrolyzers. And this is going to make huge change. Again, chemical engineering comes into picture, chemistry comes into picture, and electrolyzers have to be manufactured, mechanical engineering comes into pictures. All right. So these are very important transitions that we are right now witnessing, and we are going away from petrol and diesel. And should we go away from petrol and diesel, we have to concentrate more on solar energy, renewables, and hydrogen. Entire Japanese people are working to, they have accepted that, next 50 years is going to be only hydrogen, and onwards it's going to be only hydrogen. If by 2070 we want to become net zero country, we have to follow these patterns, and we have to go into biofuel, ethanols, and followed by LNG, and then followed by hydrogen. So if we start working today on hydrogen, 10 years down the line, 20 years down the line, we'll have green buses, all made in India. And this is where the fuel cell will come into picture. So hydrogen, the fuel cell, semiconductors, climate change is the problem that we are all facing. And we've got a big department of climate change right now. And believe me, they're all interdisciplinary. Not one branch can do changes here. We have to come together. And various professors from various departments, actually, we have got this collaborative faculty coming together and get grants from various funding agencies to develop a new technology. So CCUS, carbon capture, carbon utilizations are very important if we want to get rid of CO2 that is generated by our petrols and diesel cars. It is imminent, it is very important now that we have to get away with this petrol and diesel, and therefore get away with the dependence of petrol and diesel from other countries too. If we can become self-sufficient in hydrogen, because nobody can deprive us of hydrogen, it is only the technology that we are waiting for, electrolyzers. So a very, what should I say, a very cost-effective technology has to come in, and the students like you actually can come with innovative solutions to such problems. What you require is just, some motivation, inspiration, and somebody to handhold and mentorship. So I believe today, the innovative approach, the collaborative approach, and the interdisciplinary approach, these are the very important words. But unless the students don't get into these silos of mechanical, electrical, civil, and all that thing, because I remember in our, everybody is, what branch did you get? What branch did you get? These branches actually dissolve over a period of time. In fact, all of us today would like to work. I would like to work in material science, but somehow the metallurgy department was never sort of, keeping high ranks. Today, I believe material science plays such an important, semiconductor, what is it? Ultimately, it's material science. It plays a huge role, material science today. And I believe that instead of developing a small little technology now, I have to concentrate on systemic development. We have to come together and develop the entire system by itself, and for which we require a collaborative approach. So never say this is a mechanical engineer's problem or something like that, but I will always call all these people involved in those, and right from the beginning, if we can make a group, and especially for student community, if you can find a problem. See, problem sensing, opportunity sensing is 50% work. Once you sense the opportunity, once you sense the kind of a, let's say, business case, I talk in a business incubator language, we have to sense the business case. And once you sense the business case, there could be plenty of solutions to it, and you have to go by most cost-effective solutions and possibly the efficient way of handling these things. So I believe systemic development are very, very important. The project development, going from project approach, instead of sitting in a class and giving exams, of course, there are some core courses that have to be done. We have to have a big basket of elective, but we also, the teachers community, if I'm talking about as an Engineers Day, that we who teach, the engineers, the teachers also have to change themselves and possibly come out of with those traditional teaching, but can we teach in a different way? Can we teach in a most innovative way? Because COVID has taught us a lot of lessons. We have to make our course teaching in a most innovative manner. So I will say that follow an approach, show a three-dimensional figure, show a video in a class, use chalk and pencil, and have students enacting something in the lab. So can we have such four-dimensional working and teaching? And I'm sure students will carry those impressions and will remember your law that concept of entropy, which I teach thermodynamics to a lot of students, was such a boring concept, but possibly was taught in the best effective manner in a classroom. So teaching is an art, and importantly, all the teachers, I'll say that you should enjoy your teaching. Otherwise, teaching for 1.5 hours is not so simple. So you should enjoy teaching, and your students, you can actually make out from the students that they're enjoying your teaching or not. So I think we also have to change. The course of teaching has to change. And most importantly, I think the project-based approaches can be taken. So I'm sure this possibly becoming, one can define your credits, but I will always say that change the approach of teaching. For example, we don't teach the engineering drawing and the workshop in the most traditional ways now, because they're boring for electrical engineers and computer science engineers, but instead of that, can we teach to bring out some three-dimensional work which involve all these things? Can the student do soldering by themselves? Can they put a sensor by themselves? Can they do manufacturing by themselves? Can do 3D printing by themselves? And gone are the days that we should have to make them work smithy and all that thing, but we have to change ourselves. Ask them to develop a product. Ask them to develop a CAD drawing on a computer which possibly can be done by these students. And believe me, we cannot do that 15 days, but they will do in 2 days because they're fantastic at software handling. So they can come with a CAD drawing, they can do manufacturing, they can do controls, they can do sensors, and they can actually showing a walking robot within first year, wherein all these technologies of a CAD drawing, workshop, manufacturing, systems and control, and the software can be clubbed together. And then after that, let them go to various departments. But they would have seen what a 3D machine does, what a 3D printing does, what a sensor can do, what a video can do, and how the software could be written. And after that, they can actually put this, because you are help them in making an entire system by itself, entire product by itself. So start thinking about these manners, in what innovative manners can these students be taught and make them fantastic engineers in time to come. So I think I have reached my time, and I don't want to take important time from Dr. Manimori, because that's a very important teaching that will happen from that. Thank you very much.
Thank you, sir. Thank you for your valuable words. I request you to kindly stay on the desk. I now request Father James to felicitate our guest of honor. Thank you, Father. Thank you, sir. A round of applause for Professor Atre for his valuable time. He'll be shortly leaving for his engagements at VNIT Nagpur. His knowledge that he imparted stays with us.
Kindly take your seats. Today we have with us Dr. Manimori as the chief guest. Dr. Manimori has obtained her BE in Electronics and Communication Engineering from University of Madras in India, 1984. She has completed ME in Systems Science and Automation from IISc Bangalore. She received honorary doctorate for technical solution and crisis management by St. Mother Teresa University. She joined DRDO in Electronics and Radar Development Establishment as a scientist in 1984. She also served as the Director, Center for Artificial Intelligence and Robotics, Director, Defense Bioengineering and Electromedical Lab, CEO of Society for Biomedical Technology, and was the Chief Coordinator, ISRO DRDO Gaganyaan Program, Ministry of Defense, Government of India. Dr. Manimori has served the nation being a space research scientist for near 4 decades. It is a privilege to be graced by the presence of such a distinguished personality at a time when the nation is greatly inspired by ISRO's recent achievement, Chandrayaan. May we now welcome Dr. Manimori to address the gathering with a round of applause.
Good morning, everybody. For the small correction in the introduction, I am not a space scientist, I am a defense scientist. Okay. Best wishes for you on this 20th year celebrations as well as Engineers Day. So I am not a professor or a teacher to give a talk, right, over podiums. I am a chief coordinator and director, meaning interactive sessions and clarification or more questions I handle than lectures. So I thought we'll be interacting with you for an hour at least. I thought in between we will take 10 minutes. We will stop and ask session of you to interact a relevant question. So I'll be coming down, fine. So my topic today is on indigenous human life support system for Gaganyaan program. Gaganyaan program is the ISRO's program or India's program of first Indian human spacecraft in space, Indian to space and back. Okay, these are all what are all the posts I held. So Gaganyaan program is taking the human spacecraft to lower Earth orbit in the short term. They are saying 3 days to 5 days, and foundation for a sustained human space exploration in the long run. So they are planning to take a human space flight center as a separate department. So subsequently we may have, in your terms, not in my terms, 10 years, 20 years down the line, India may have its own space station in the coming decades, probably. Okay. As a part of this mission, 2 unmanned mission and 1 manned mission is sanctioned by Government of India. So, Gaganyaan takes the GSLV Mark III as the rocket. Now this is called Human-Rated Space Vehicle Mark III as a recent name. It has an orbiter module where the astronauts, they are called Gaganauts, will be staying 3 to 7 days in space. So indigenous human life support system, what I am planning to talk or I have contributed as a coordinator is these systems, a continuous wearable human health monitoring system, a medical kit, astronaut food and accessories, fire support system, an ANC headset, radiation level monitoring system, and parachute system, and emergency survival system, and life raft. So I said this is the indigenous human life support systems. I want to ask a question now. So can you say what is the important human life support system is missing in that? Yes, oxygen is missing. Yeah, when you go to space, oxygen is required. So it is the space suit which provides the oxygen, and the what you call the orbiter module is holding the oxygen. So the heading is indigenous. So that is not indigenous. That is imported. Space suit is from Russia, right? Okay. Any other thing missing? Fine. So at least after a long talk, you are alert. Okay, we'll continue. So DRDO labs, 8 labs, have signed the MOU with ISRO in September 2019 for the development of this above 8 technology. I'll just go back to the previous one. There is a space between the first half 6 and the second half 2. Is a mistake or intentional? Is there any difference? Isn't it? They are grouped as 2 sets. Some guess. Yeah, you are right. The first half is requirement in space. Second set is after returning or while returning. Right. So the 8 labs are these. You can call it ADRD Agra and Double Bangalore. When it was signed, I was privileged to sign as a director double this MOU, and DFRL Mysore, and DPAS Delhi, INMAS Delhi, CIFIS, and Defense Lab Jodhpur, TBRL Chandigarh. So Professor talked about ISRO labs, URSC, LPSU, all of you know, but these labs you may not know, isn't it? So DRDO works as 7 clusters for defense. So the clusters are towards the R&D of the corresponding warfare. So there is a Army Research Labs, R&D for Army, Naval Research Labs, R&D for Navy, Aerospace Research Labs or Aero Labs, R&D for Air Force, and Missile Labs, R&D for missiles, and Electronics Labs, R&D for communication and electronics warfare, and Life Science Lab which support life system and CBR and mitigation technologies. So as I was double director, I was under the life science cluster, and life support systems was the ISRO's requirement or a first human spacecraft. ISRO is launching satellites almost 40, 50 years, but this is the first life-based, forget about not only human, even human and life spacecraft. First time we are scheduling in Gaganyaan. So the nearest R&D is in the area of aerospace in India. Aerospace research is done by DRDO for Defense Indian Air Force. So they approached DRDO labs and we have signed the MOU. That's the background story. And ADRD Agra gives the parachute aerospace, Double gives the crew health monitoring and survival kits. DFRL Mysore gives the food science, food. DPAS gives physiological monitoring of the astronauts, and INMAS gives the medical kit as well as the health monitoring. The doctors are along with IAM, Indian Air Force, monitors the health of the astronauts. CIFIS gives the fire extinction vans. Jodhpur lab gives the radiation monitoring, and TBRL Chandigarh gives the testing facility on impact while launching the impact of the blast on the spacecraft, because it is the first time human is going to be inside the spacecraft. Before going further, so the manned mission, we have put this side, a picture, nice picture. This was 2019 plan. So we are in 2023, right? So there is a lot of changes would have been there, and further changes may happen, right? So can you ask some questions before going further? Regarding Gaganyaan, of course. Yeah, this side.
How much time this total project will need?
Gaganyaan project or our developments? That ISRO have to answer. You can check in the website. I can tell about this MOU related life support system. Double, if you ask, we were working for the health monitoring. I'll just show in the subsequent slides. Past so many years for aerospace pilots, okay, the PP, VPM, the monitoring wearable instruments, we were working almost 10, 20 years. So that is why ISRO selected us to develop the crew health monitoring. Only thing is, first time we are going to space grade these products. Earlier it was only defense grade for pilots. Now it is going to be the space grade. That is the first difference. The second one, the space, if you asked me, regarding the emergency survival kit and life raft, we are already giving to Navy as a ESK. And it is the same product because it has to be space graded as a storage item. It should go to space and come back. Otherwise, operational requirements are one and the same. So what will I say? These products are not from the first onwards to be, I do not know, maybe decades. Just for the project wise, we have signed 2019 for the manned mission of 2024, which is scheduled, or unmanned vision 2023. And I can say for sure, I am not sure all the 8 products will fly in Gaganyaan, even though 20 years of research is used. Because of space qualification and certification requirements. However, upcoming space flight, Human Space Flight Center, HSFC is planning maybe in the coming years many manned missions. So sometime it will be used. Even though this MOU is signed, we are committed to deliver, but we are not sure the acceptance level of only space grading. As per ISRO's website today, the crew model parachute system is cleared for use in Gaganyaan out of 8. And of course, astronaut food accessories also clear. The reason being, earlier we have given an Indian astronaut food. Do you know who is it? Earlier, Indian astronaut float. Seniors, I should ask, the era belongs to them, no? Do you know who is the Indian astronaut? Of course, the mission was not Indian.
Rakesh Sharma.
Correct. Rakesh Sharma. Actually, in the Gaganyaan boards, we call it as Advisory Council. Rakesh Sharma is there in the board. So, for him, we have provided the food when he went to space. So, it is a proven technology. The food is, so sure it will go this time, 100%. And parachute system, their website said it is clear. Okay? Good question, good question. So, even though you sign a MOU, even though you develop the system or a big programs, go for a redundancy, parallel development, contingency plans, and very heavy review mechanism, or what will I say? tedious review mechanisms. Okay. So these technologies we are working for the last lost so many years, and based on that, we are planning to develop BioWest, and this is up to 2022, which of the model which will be accepted and developed to the mission, I am not very sure. But I can tell the difference of what other countries are developing or not, on the difference what we are developing. We are planning continuous health monitoring of astronauts. So before, when the launch happened, before the astronaut said, "Hello, I am fine," we wanted to see from here whether he is fine, the doctors. Whereas maybe they are sending astronauts for so many decades, so they are not interested, they are not using a continuous health monitoring, right? So what we do in the health monitoring is the vitals as well as body temperatures we measure and transmit via the mission computer. The doctors will be staying in the ground station in either in Bangalore or launch time in Sriharikota, SHAR Center, and monitoring defense doctors as well as DRDO doctors will be monitoring. So these are all the measurements we check by a wearable vest: ECG, heart rate, oxygen temperature, skin temperature, respiration, and blood pressures. The problem is this can be, as on now, for the normal people, not in space application. Itself is not yet ready. You may not see in wearable vest, contact like ECGs, as a normal human being in Earth. So we have to develop that as well as get it space graded. And it has to be acceptance level of the astronauts. Astronauts should say that I like to wear this vest under my space suit, isn't it? So before going to the medical kit, So in your opinion, what kind of medicines may be required for astronauts? A sick person are we sending? Are we sending a sick person?
Digestive medicine.
So why medicine is required?
Antibiotics.
Why? Question is fit. Why?
Yeah,
you want
why?
medicine?
Just, if they get ill, so that's
Because in space, there can be any kind of changes in craft which we do not know.
They are well trained. Training has been given.
Ma'am, here.
Lift your hand. Yeah. Tell me.
The medicines to control blood pressure or dizziness in space.
He is well trained so that his blood pressure, 2 years training is given so that his blood pressures are normal. Any other? Actually, you would have seen in these kind of meetings, outside ambulance is kept. Why? In case of emergency readiness, it's or fire extinguishers are kept in every building. It is just a preventive methodology. It is not a planned action. Okay? So the kit has for crew comprehensive medical kit, motion sickness or trauma sickness, then emergency survival kit after landing also will have some medicine, then medical trash bags and personal hygiene kit. Of course, personal hygiene kit is required, correct? So these are all some examples which initially we thought of and proceeded up to 2022. We do not know finally what will go. Okay? You can see that the sickness goes in a patch that you can apply over the body. Then injections, because we are not sending doctors. He has to inject himself, right? Then paracetamol, if he gets mild ear allergies because of the launches. Then respiratory problems, right? Then eye drops. Then some wounds have come, silver sulfadizing. Then sleep and alertness, he has to work continuously. If so, some alertness, or if you have to get sleep, some pills. And all are precautionary except hygiene. Now let us say about the food, right? So some people used to think they used to take only capsules. So they were taking high protein bars with fiber, like almond chickpeas or groundnut chickpeas, you know. But it is proprietary made in DFRL, nutrition experts, and water pouches and cutlery, and the food heaters. By suppose if they are eating some pulavs, so they can heat it and eat, and trash bags, of course. I like to say we suggested edible cutlery, so that I thought one trash bag number will be reduced, and as well as some appetite also they can use with the edible cutleries. But it's not popular, right? Do you like edible cutlery?
No.
So they also didn't like it. So of course we are not expecting fire inside the spacecraft. As medical, this is also preventive. We have two fire extinguishers. One is automatic, which can be tested or controlled from ground station as well as automatically by themselves. Second one is the crew can use the fire extinguisher. Before going to the parachute system, can you say, is this preventions are sufficient or some more are required in your opinion? If you are going to fly, what? If you are going to go space, anything more is required in your opinion? No. So there is no walking support is given, right? If you are seeing, isn't it? I have not talked about any walking support, standing support, right? So as on now, the spacecraft is 410 space crew module, where probably the astronauts may not be walking, they will be seated. Now, this crew parachute system, which is a success story. So, why we call it as parachute system instead of just parachutes? Mechanical engineers. Ah, they are, not you, right? Computer science engineers. So, Professor told we cannot have one department alone, right? So, it is called system because it has auto firing methodology as well as computerized ignitions, right? And the design of the parachutes and the reliability. So, how many parallel failed conditions it can handle. So, we call it as a parachute system. Any idea how many parachutes will be there in the parachute system? Of course, the figure shows two.
Two.
That is the last two main parachute. The figure, this side we have written 4 types of parachute. Most of it are written as parachutes. That is plural. So 4 into 2 minimum.
Yeah, actually, there should be 3. Yeah, there are 4 types. Yeah, one is for emergency. Yes.
No, total how many in your opinion?
Yeah, there should be 4.
4.
Yes.
Each is written suits. See, 4 types. Each one is written as suits, plural. Anybody else? This side.
Maybe number of astronauts.
No, this is for the crew module. It is, the astronauts will be inside the spacecraft. This is the spacecraft coming down. We call it as crew module.
No idea.
Read, no? Nothing wrong in trying. The learning is part of interacting.
10.
Yeah, it's 10 parachutes. You can see as 4 different kind. So 4 into 2 is 8. Actually, that is totally 10 parachutes because one is a redundancy, one set. Instead of 2 main parachutes, 3 parachutes are kept so that one can be as redundant. On one failed condition also, the parachute systems can be used. Now let us say how to test these parachutes. Mechanical engineers, 3rd year mechanical engineers, lift your hand. No 3rd years here? All others are happy because it is not directed to them. How to test the parachutes? Yeah.
Testing of parachutes happens in wind tunnels where the parachute is stationary and wind is blown in it.
Yeah, one way of testing wind tunnel. Good. Anybody else? Anybody else? We don't have textiles, but we have materials department, right? Material science. Lift your hand. No materials people? You don't have material degree? Don't want to say yes or no? Right. So, we can test by simulation, FE methodology, computer science, CAD CAM. Nobody is lifting hand. CAD CAM, M-Tech is there. Hands have been resting or tied. So you can simulate situation that is only in the design stage. Okay. Once design is over, we can test in 2 dimensions. One is called drop test. You can, like a human being is paratroopers we call, they jump, right? So like to that, this can be dropped. Like weapons are dropped during emergency, food materials are dropped during disaster. That is called drop test. The second one is the space to entry face a high speed of entry to Earth atmosphere. So that we call it as rail track sledge test. Okay. Now we'll skip this. We'll go to parachute testing. I don't know. Go back. Drop test. These tests are completed and ISRO website says this is the only item successfully tested as on today's one. And few days back it has come in paper that these tests are successful for main parachute. So 10 parachute system, we won't test together. Each parachute we will test by drop test. Each parachute we will test by RTRS, that is rail track rocket sledge test. That is in the land we will speed it up to 400 kilometers per hour in that rail track and open the parachute and see that it is functioning. So the rails to speed up to 400, 500 kilometers, mechanical engineer, how will you do that? What kind of engine to use? So what is the speed at present the trains are running? 200 kilometers per hour, 240. Cars, motor. Your cars are running what speed? 200, 250?
240. 240.
240. Now I am talking double the speed, right? Two motors. It will become 500. It will become 400. So they use a rocket. They use a rocket, pyro or rockets to fire this, what do you say, in that rail track. That is what rocket sledge test, sledge. This is done in TBRL, Chandigarh, where we test our missile testing. So once drop, you can see that I am inspecting the parachutes. So depends on the height, the drop zones will be there. So we have tested almost 500 feet, 10,000 feet, 1,000 feet, not even 10,000 feet, 1,000, 2,000 feet. So these are all called drop zones. So once it is dropped, we are seeing here you can see ISRO coordinator and ADRD coordinator and HS sub C. ISRO also has rocket side VSSC and Gaganyaan side HS sub C. So these assignments should be taken very collaborative way, and we cannot find who is faulty and fight when things are not all right, isn't it? So we have to learn to work in a collaborative system-based developments. Now we'll go back and show you one picture about rocket sledge motor where it has come in paper before going for any other questions by you.
Ma'am, in your whole presentation, you tell us about food and accessories. You tell us about some preventive measures, but you don't tell regarding how we manage the unnecessary waste provided by the particular astronaut, maybe female or male.
Good question. So I have given some waste trash bags, right? They have to manage, otherwise diapers. Any other question? Question. See, Indian scenario, knowledge is by that, meaning you will learn only if you ask question.
How will you test the life support system, considering we can test a parachute system by just drop testing, but how will you test the life systems?
Yeah. So there are 8 life support system I will explain. Let us see food. Okay. So let us see how foods are packed and given, okay? In a ESK, let us say. So you can see the bag, emergency survival kit bag, like that only foods are packed with the food bags also. You can see layered bags, and this will be, consist of 15 items and a 3-man dinghy as well as beaker. So these are all the things. You can have water pouches, food, and fishing kit. By suppose he gets bored after landing in the ocean. Then first aid kit again. Then salt and sugar, heliograph, distress. Heliograph is like mirror. So if he is in the ocean, he can reflect to the helicopter so that sunlight, so that they can pick up. Then distress signal is like firecrackers. They burst so that it can be. So flare also similar to that. And watch so that he will know where he is. And goggles, by suppose shark comes, so that shark repellents. And a Swiss knife and lights and some cells are kept. So they are arranged inside. This is kit. This is the dinghy. It will be packed condition. This is when it is fully open. It is on touch of the sea or touch of the water. It is auto-inflatable with cylinder. So actually for naval application, we are giving carbon dioxide and a big cylinder. Here reviews were saying carbon dioxide in space may be not considered for human health, so they were telling nitrogen, something like that. I do not know what the end will be given. So the review, first one said carbon dioxide is not acceptable, and that's called human rate review. Second review told safety review, high pressure is not acceptable, so that auto inflation. So we said let the astronaut blow, then after coming back he won't have energy to blow it altogether. I do not know at the end what is accepted. After the 8 rounds of reviews of space, safety, whatnot, right? So this is how they are packed. And testing is, the standards are given, you see, where they are. So each of the things should meet packed condition, some of the standards, you see, correct? For space flight, it is written, no vibration standard, this standard, that. They are tested in that conditions. Any other question?
Defense grade project to a space grade project.
Very good question. I told about this first, what is that called? Health monitoring. Double is working in health monitoring 20 years. And these products have been developed not for astronauts. It is for aerospace application of pilots, fighter pilots. Past 20 years, and it is the technology finished grade and ready to PPVPM and all supplier ready grade. To space qualification, we have signed MOU for the 4 years. I am not sure it will fly. So that's what I am saying, where collaborative approaches are used and transparency is kept. The more your design, you are transparent, somebody else will find the problem and review and solve. That's why I shown in the parachute as a team is standing, but it is not one team. It is defense, where the paratroopers are army people, and the flight is Air Force flight and tested in Air Force drop zone, and the dummy satellite is L&T's, and the parachute design is by ADRDE. The first cutting pyros are from VSSC ISRO Trivandrum, and the whole in charge of that program is Gaganyaan, which is having a director and portion of HSFC, Human Space Flight Center of ISRO Bangalore. So all the team should work as single team in a transparent manner of 24-36 months with 8 to 10 hours of reviews, demonstration, then success is possible. But I don't want you to derail your interest. Pune University has done a spacecraft, not a human one, normal spacecraft, given to ISRO for launch and successfully cleared. I don't know whether it is launched or not, but cleared for launch. It took some 4 years. Most of them are students. They had some philosophy. The 1-year student work, he gave to the next batch of students the total knowledge together. That's what Sir was telling, no? Collaborative, transparent methodology you can achieve from what you call, from initiation to space grade quality in 4 to 5 years. Right? Any other question?
Ma'am.
I'm not. Where I am not. Lift your hand, otherwise I'm not. Yeah.
Ma'am, the space station will revolve around Earth or will be at a static area just like?
First, if you put anything above Earth, either it should touch Earth by the gravity, or if you escape Earth, it should rotate around the Earth. That's the first slide, right? I have shown. Okay. We are planning for 400 kilometers, I believe. LEO, we call low Earth orbit. Back.
Ma'am.
Yes. Lift your hand.
As NASA is planning Artemis 3 in 2025 and there is Gaganyaan, NASA is going to research on the South Lunar region. What is the main research plan of Gaganyaan and what are the major differences between ISRO's project and NASA's project?
Very good question. Let us clap. We are comparing crawling child to a professor. But still, we are aiming to be the 4th nation in the world. And indigenous capability is very important. At least COVID has shown that. If you see oxygen cylinder, indigenously we have not developed oxygen cylinders. We used to get shipload of empty cylinders. Shipload, what you see that 47-liter cylinders are important ones. Once COVID came, whole world said no cylinders. Then we have used aluminum cylinders, 20 liters, right? We have testing facilities. So indigenous capability has to be developed, right? One day or rather. So it is, we are starting into the human spacecraft era. So government has established the establishment for human space research center, flight center, for a series of flights. The first program human flight is Gaganyaan. Till now we didn't have not even one human spacecraft, right? This will be the first human spacecraft. It is going only LEO. It is a first step. The long run is human space stations. Very long run. We'll stop. Yeah. Go ahead.
Ma'am, if like the mission is too long, 10 years or more than 10 years, how will the food and materials will prevented, like not expiring or all?
Yeah. This is the thing on estimation I have not done properly as a coordinator. So you could have seen that we have signed the MOU 8, MOU costing around 100 crore. Thinking I will produce one item and we will deliver them, right? Time schedule we have put. I didn't realize, you see the dinghy, first we have realized the dinghy with carbon dioxide demonstrated, went to the specification approval review. I thought, over, fantastic, I am so ahead, I am showing a model, touching it, showing it water, floating, 3 people are sitting. I thought, overdone. He said, yes, you have capability. Go for next, carbon dioxide not accepted. The next model, we put something else. Then the safety fellow said, no, high pressure not accepted. Then we went to low pressure. Then the mass fellow said, this size not accepted. So everything repeat. So 8 to 10 models, we have only exhibitions. So the last approval one, you have to have, that's what as any material person or MBA you may be saying, the supply chain quality. That is, I cannot buy the supply of the item at the end. I have to buy the total supply in the beginning, check the quality, keep it ready, and make the supplier ready to give the same quality in the last 24 months or 12 months. I think you are catching my point. That's what we missed, saying that I have put 1 crore, it ended up 10 crores, 10 times. Because estimations we never seen first time we are entering into the space domain. It's a very good question. For example, medicine also. Medicines are having expiry of 12 months. And the last medicine, what we want to give them expired one or ready to expired one. We want to give that one as a fresh stock. So that stock we cannot acquire and keep it, or we have to identify the company and make the contract with them to develop when the project gets scheduled correctly. MOUs has to be developed. Agreed.
Ma'am?
Any other question? Lift your hand. Yeah, go ahead.
Ma'am, what are the challenges an astronaut will face during the mission?
Very good question. Once again. So, this time we have selected the astronauts, test pilots, test fighter pilots of India from Indian Air Force. So, they would have had enough flight challenges faced people with the fitness. Then subsequently they have to face the challenges. First challenges is our indigenous vibration, takeoff times, the noise, right? The safety, health, and whatever testing they go through, the real things are may be different or may not be different. They say the pilot trainings have been, they underwent with Russia. Their astronaut says that training to the real flights, astronauts do not see any difference. They say. So these challenges are faced with training, including 0G, where the G is the one where we find the blood circulates all around us, able to walk, all those things. So this time astronauts, they are not very mobile condition they may be planning. So it is a tough space, crunched area. They have to stay, they have to do assignments. Yes, it's a great challenge. We actually India wants to, we means Gaganyaan team or India wants to mitigate with training, knowledge and the reviews. All these products are reviewed by the astronauts and their acceptance are looked after. Second one is unmanned mission. We are holding unmanned missions. Without them, dummies will go with all the equipments, and from here we will remotely monitor. This is the plan to mitigate. Right. I think I'll close this presentation.
Thank you, ma'am. Ma'am, kindly stay on the dais. Thank you for a very interesting and interactive session. I would now request Professor R.B. Govardhan to felicitate our chief guest.
let me take this opportunity to thank both the invited guests for their valuable time and knowledge sharing. To my beautiful audience, thank you for your patience and keen listening. A big thanks to entire organizing team. Let us all rise up for the national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा राविर उत्कल वंगा वृंद हिमाचल यमुना गंगा उच्चल जलधि तरंग तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगल धायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. Students are requested to remain seated. The volunteers will lead you batch-wise to the refreshment counters. After you collect your refreshment, you are requested to proceed to your respective departments for your regular academics from 12 noon sharp. I request all the student volunteer to coordinate. Dear faculty members, the refreshments for the faculty members will be made available